All right, so I'm at school. Sorry about the lights overhead. But yeah, Rob and I were working on, we were just looking at the final notes for the exam, and we were going to do some of the complex functions because we haven't really gotten many questions on them. So we did have this one on the recitation, so we decided to do it. So I'm just going to walk through this. So the cosine of a complex number is given by this formula. That's one of the ones you just got to remember. So we were given this complex number, 3 minus 4i. So we're just going to plug in z here. So we're going to put this here, and then what we're going to do is distribute that negative I over to here to get this, remembering that the I is the square root of minus 1, and distribute this I to here. Then what we can do is, using Euler's identity, we're going to say that minus 3 is this angle, and we're going to, because this is the same thing as e to the minus 4 times e to the minus 3i, and you can rewrite e to the minus 3i as this. And same thing goes for this guy here, except we got an angle of 3. Now remember, in some trig stuff, if you take the cosine of a negative number, a negative angle, it's the same thing as taking the cosine of a positive angle. And if you take the sine of a negative angle, it's the same thing as negative the sine of that same angle. So that way we can have it all in terms of just 3. We can factor out what we need. So this becomes this, and that's an acceptable final answer. So that's cool. Here's an exponential function. So e to the complex number z is the same thing as e raised to the real part. So in our case it was 2. And cosine of this guy here, this angle y, this is the imaginary part. So we're going to just plug that in. These ones are pretty easy. So you just turn it into that, and then if you want, you can distribute the e squared and take, well, luckily we had a reasonable, well, one I know, and then we'll go with that. So that works. We didn't do a sine one, so we just made up one, and it's 2 plus 4i. So the way we can remember this formula here, it's the same as the cosine, except it's got negative, and these two negatives are attached, and sine has an I, so you remember to put the I down the bottom. Rob came up with that. I like it. So yeah, you just plug in the complex number, distribute the i's as we did before, and then you go ahead and rewrite them in terms of Euler's good stuff, and using that same trick we used before. I think that this is right. Yeah, because we can cancel out the i's here, but this negative I is the same thing as 1 over I, apparently. So you're going to end up with something like this. I think that's an acceptable answer. I may have made a mistake on that, but I'm going to leave it as such. Plugged it into Wolfram Alpha, but you get about like 40 different answers. I can't really tell if this is in any of those forms. Maybe I'll take a calculator later and figure that out. And then for logs, you just memorize this formula. So this one, the trick to it is you take just draw your complex number on the plane here. So you take minus 3 and plus 4i. So that's pointing up this way. So the argument of z, well, it's not just the tan inverse of this guy. If I took the tan inverse of 4 over negative 3, I'm going to get this. But keep in mind, we want this angle here. But if I just take 4 over 3, and take the tan of that, that'll be this angle. So I can take pi minus that angle, and that'll give me my theta. So that's why I put it here. And then you add I plus 2 pi k, and k is an integer, so you can, because it's periodic. But yeah, so that's all there is to the complex trig functions.